Morning students, in our chapter motion in one dimension, we have seen that if some body in motion covers equal distances in equal intervals of time, then we say that the body is moving with uniform speed. And if the body keeps on moving along a straight line path, then the speed and velocity are the same. Now, practically the bodies does not move with uniform speed, or they move with non-uniform speed, means there is always a change in the velocities. Means sometimes the speed or velocity may increase, or sometimes it may decrease also. So in case there is increase in the velocity of a body, then we say that the motion is accelerated motion, and if the velocity is decreasing, then we say that it is a deaccelerated motion or retarded motion. So now let us say that some body moves along a straight line path, and initially at 0 second the velocity is u, so we are representing the initial velocity by u. And after some time interval, let us say that at t seconds the body acquires a velocity v. So this u is the initial velocity and v is the final velocity. Then we say that in a time interval t second the change in velocity is v. So in time interval of t second, the change in velocity is equal to v minus u. And if I divide this change with time, so I get the rate of change with time. So this rate of change of velocity with time is called as acceleration. So we have also already discussed in speed. In t second, the change in velocity is v minus u. Therefore, in 1 second, this change will be equal to v minus u over t. So this change in velocity in 1 second is called as acceleration. So we represent this a by a is equal to v minus u over t, and we say that the rate of change of velocity with time is called as acceleration, or the time rate of change, or the time rate of change of velocity is called as acceleration. Now looking at its unit, so acceleration units are, so this change in velocity will have meter per second and time will be t, so unit becomes meter per second square, so it is represented as ms raised to power minus 2. So the SI unit is meter per second square, or its CGS unit is centimeter per second square. Now we have to talk about the value of a. So looking at this expression, a is equal to v minus u over t if the speed is increasing, means I'm saying that the value of this final velocity is greater than the initial velocity, then this acceleration will have a positive value, so it will be positive. So this will be called as the accelerated motion. And if the final velocity is less than the initial velocity, then this will be negative, so this will be called as the retarded motion. So this is the case when v is greater than u, and this is the case when v is less than u. So acceleration may be positive or negative. Acceleration is a vector quantity, so it is a vector quantity, and the direction, so direction will be same as the direction of change of velocity, so it will be in the direction of change in velocity. Now uniform acceleration. So if the change in acceleration is equal in equal intervals of time, then we say that the body is uniformly accelerated. So means value of v minus u will be always equal in equal interval of time. And non-uniform means the change in velocity will not be the same in same intervals of time. So that body will be called as moving with non-uniform acceleration. So v minus u is not same in equal intervals of time. Now next quantity or next term that for which we have talked about is the acceleration due to gravity, and that is represented by g. This is called as acceleration due to gravity. And if some body is falling downwards, then it is represented by plus g for downward motion, and for upward motion it is represented by minus g. And the value of g is 9.8 meter per second square. This acceleration is due to the gravitational force of attraction, and its value is 9.8 meter per second square. So that means if somebody starts falling, so then if something is dropped from certain height, then after 1 second it will acquire a speed of 9.8 meter per second, and after one more second it will acquire 2 multiply 9.8 meter per second velocity and keep on increasing with time. So this is the meaning of this g. And we have to remember one very important thing regarding g. This g is independent of mass. It is independent of mass, means for different masses the value of g or the acceleration will be same. Means if some body of mass 10 gram and one body of 20 gram are falling simultaneously, then they will reach to the ground in equal intervals of time if they are dropped from the same height. Now I think that you can complete your exercise. So have a nice day. Thank you.